All right, so last section we're going to take a look at this week is 2.1, and it's on what we call zeros of polynomials. So yesterday we talked about zeros of quadratics, right? And a zero is basically where the graph crosses what? Yeah?
The x-axis.
X-axis, yep. So we're going to talk about where graphs cross the x-axis, but we're not going to talk just about quadratics. We're going to talk maybe about something that has exponents higher than 2, like a 3 or a 4. And we'll do some sketching on the calculator and see how that can help us. All right, so let's graph that equation. And let's see how many times it crosses the x-axis. So I'm going to go to y equals. Type in 2x. And remember, when you do the third power, unless you press the right arrow, your cursor is going to stay in the exponent. But I want to get out of the exponent. So just press the right arrow. Minus 3x squared minus 3x plus 2. Okay, when we graph it, what's the zoom that we generally start with, and then we work from there? Yep, so we're going to do zoom 6, and that window's fine. That's a good window. It shows what it should look like. And now we can answer the question, how many times does that graph cross the x-axis?
3.
Yep, it crosses 3 times. All right, now let's look at that a little bit closer. Okay, so here's our graph. Let's put that there. If I were to find the coordinate here, here, and there, what would the y value be of each one of those coordinates?
0.
Yeah, it would be 0. Any point that's on the x-axis hasn't gone up or down at all. So the y value would be 0. Okay, so you might hear me use the word zeros. You might also hear me use the word roots. It means the same thing. So what this means, because the graph crosses the x-axis 3 times, is there are 3 numbers that you could fill in for x in each spot and get an answer of 0. There's one number over here, one right there, and another one there. Okay? Yeah.
So do you actually need to graph it, or can you just look how many x's there are?
So one thing that can help you is not looking at how many x's there are, but looking at that highest number. That number doesn't necessarily tell you how many times it crosses, but it tells you how many times it could cross at most. Right? Because if I had something like, let's see if I do, just change this a little bit, put plus 9, see if it does what I want. Yep. Okay. So look at that one. Still has an exponent of 3. Right? That's still the highest exponent. Still 2x cubed. But how many times does it cross the x-axis now? Once. So this number, the highest exponent, is an upper limit on how many times it could cross. Just like with quadratics. Quadratics, the exponent is a 2. And a parabola can only cross up to 2 times. It could be less, but 2 is a maximum. All right, so let me graph what I have in parentheses right there on y equals, and I'm just going to put it in y2. I'm going to do x plus 1. I'm going to do 2x minus 1. And I'm going to do x minus 2. And I have to change it back to what it was originally. I made it a plus 9. What was it before? Plus 2. Plus 2. Okay. So I'm putting back in the graph that I had. And I'm going to graph what's written on the board right there. And I want you to see how they compare. So there's the original. Now tell me how the one in red compares to that one in blue. Yeah, they're exactly the same thing. Okay, traced right over it. So that means somehow whatever's written right there is exactly the same as what's written up there. And if you multiplied it out, you could check that. You'd have to FOIL it. Does anybody remember what you call it when you write something like that? You have sets of parentheses. A lot of times you just have 2 of them. This one has 3 sets. It begins with an F. Yeah?
I was about to say a trinomial, but
Anybody remember what you call it when you do this with quadratics a lot? You write 2 sets of parentheses and you make it look like that. Yeah? Factoring, yeah. So this, what I underlined in red, that is the factored form of what's up here. For now, you don't have to know how to change what's up there into what's right there, even though they are the same thing. Okay? You don't have to know how to get that. But what I want to do is I want to take each one of those factors and I want to set them equal to 0, one at a time. And I want to show you what happens. So let's take the first factor, set it equal to 0. Take the second set of parentheses, set it equal to 0. And take the third parenthesis and set it equal to 0. And let's solve each one of them. What would be your first and only step to get x by itself in this first one? Yeah.
Subtract 1 on both sides.
Yep, subtract 1 on both sides. So we get x equals -1. All right, let's try it here. What would be your first step to get x by itself in the second one? Okay, so we're going to add 1 on both sides. And your last step would be to
Divide by 2.
divide by 2. And that gives me x equals 1/2. And what about on the third one? Yeah, please.
add 2.
Add 2 to both sides. We get x equals 2. Okay, so look at the 3 numbers we just got. -1, 1/2, and 2. Yeah.
Do you have tissues?
I don't have tissues. I only have those paper towels over there. They're kind of like 80 grit sandpaper. Yeah. So yeah, I get -1, 1/2, and 2. Look at this graphic. What do you notice about the 3 numbers that I just said? -1, 1/2, and 2. Yep.
Those are all like where they intersect on the next one.
Yeah. -1, 1/2, and 2. Those 3 numbers that we just got are the 3 values that tell us where it crosses the x-axis. When you write something in factored form, it makes it much easier to figure that out, because you can take your problem and we're really breaking it down into littler problems. In this case, it was 3 littler problems. When it's written like it is here, it's very hard to figure out that -1, 1/2, and 2 are the numbers you would be able to plug in for x. So that's the advantage of factoring it. Yeah, it
Do you
doesn't.
have pencils?
Yeah. All right. So any questions on how we got those 3 numbers? Now, the calculator can also help us with that. Go back to the graph, and have we done second calc 0? Yeah. Okay, so let's do that. Let's do second calc, and we're going to calculate the 0. Now, there are 3 of them, but the calculator can only do 1 at a time. So when you do second calc, and you pick option 2, which is the zeros, it's going to ask you 3 questions. Okay, the first question it's going to ask you is to pick a point that you know is to the left of the 0 you're trying to find. Okay, I'm going to try to find the one that's on the right side. So pick a point that you know is somewhere to the left, and then you hit enter. What it does is it puts a dotted line, and that's like a boundary of where the calculator is going to look. Then I need to use my cursor and pick a point that I know is to the right of where it crosses the x-axis, and hit enter. If you've done that step right, you should have 2 dotted lines if you're using one of my calculators. If you have your own, it might be a little different. But on mine, it should show 2 dotted lines, and that's like the zone it's going to look in to find where it crosses the x-axis. The last thing is the guess, and I just put it kind of close to where I think it crosses. It doesn't have to be exact, but you hit enter, and then it tells me one of the zeros. It tells me one of the zeros is when x equals 2. If I wanted to get the other ones, I'd have to do that process again. Second, I can show you one more time. Second, calc, 0. Okay, let's do the one in the middle. Pick a point that you know is to the left. Pick a point that you know is to the right. Okay, and there's the zone it's going to look in. And I try to make sure when I do that, that there's only one place it crosses between those dotted lines. Okay, so it can only find one at a time. And again, the guess, we just put it kind of close. Hit enter. And it doesn't give it to me as a fraction, but it tells me another one is 1/2. And that's what we got as well. Okay, so that's handy if you're not able to figure out how to get this, the factored form. The calculator can help you to get the answers. Any questions on that? So those 3 numbers that we found, -1, 1/2, and I think it was 2, those are called the zeros. If you write them as a coordinate, then they're called x-intercepts. Right, if you write like, whatever it was, 2, 0. 2 is the root, 2 is the 0. But when you write it 2, 0, that's a coordinate. That's how you write an x-intercept. So writing roots and writing x-intercepts, it's almost the same thing. The only difference is a root is just a number. An x-intercept is a coordinate. And on some calculators, if you have an older one, instead of doing second calc and it having it say 0, you might do second calc and it'll say root. Some older calculators, that's what they say. All right, so let's think about a line. When you have a line that's not horizontal, how many times can a line cross the x-axis? Oops.
If it's a linear line once.
Yeah, if it's a line, just once, because lines don't curve. If it's horizontal, it might not cross. That's different. If it's not horizontal, it will cross once. If I wanted to solve this equation and get the x by itself, can anyone tell me the first thing I would move to the other side? Yep.
The B,
Yep, and how would you move the b to the other side?
subtract it.
So you'd subtract the b, and then you'd have something like this. And how would you move the a to the other side? Yep, and what would you divide by? A. So when you're solving a linear equation, and you want to get x by itself, you subtract the b, that's why it says -b, and you divide by the a. This formula is kind of like the quadratic equation for lines. It's much simpler because it's not a quadratic, it's a line. But -b over a is the formula to find the answer to a linear equation. When we get to a quadratic, this formula gets a lot more complicated. That's where it's the negative b plus or minus square root of b squared, 4ac all over 3. It gets a lot longer. Okay. So let's try that on this one. So we want to solve that to find the roots. Okay. I know that I'm finding the roots because it's equal to 0. That's what finding the roots means. Tell me the number you could plug in right here so that if I do out the arithmetic, I'll get an answer of 0. And that's where it'll cross the x-axis. All right, so what would be my first step to get x by itself? So subtract 3 from both sides. So that's gone. And my last step, divide by 2. We get x equals negative 3/2. Right? And if I plug that in on the calculator, where do you think it'll cross the x-axis? Negative 3 over 2, which is negative 1.5. Right? It's going to cross right there. I don't know if you can see it well, but it is crossing at negative 1.5. Now, if you do second calc 0, the calculator never gives you a fraction as the answer. It would say negative 1.5. Any question how you calculate the 0 using the calculator? Pick a point to the left, to the right, and then the guess. Okay. All right, so lines are, again, very straightforward. You only have to look for at most one answer. Okay. This is now a step up from a line. Okay. Highest exponent here is a 2. What do we call an equation where the highest exponent is a 2? It's a quadratic. Quadratic is a parabola shape. Okay. This is what we studied yesterday. How many times can a parabola cross the x-axis? At most, 2 times. And the other thing that we talked about is there's a quick way to figure out how many times it crosses if you do that calculation. B squared minus 4ac. Okay, there were 3 different things that could happen. It could come out less than 0, equal to 0, or more than 0. If that comes out less than 0, does anybody remember how many times that means it crosses the x-axis? Less than 0. Yep.
Twice.
Um,
Wait, no, sorry. Yeah, it's just twice. Oh, no, not.
9, yeah. So if it comes out less than 0, it crosses 0 times. What if it comes out exactly to 0? It crosses once. And what if it comes out b squared minus 4ac is greater than 0?
Twice.
Then it crosses twice. Right? So what it doesn't tell you is where it crosses. It just quickly tells you how many times it crosses. If you want to know where it crosses, you've got to do one of 2 things. You either can factor it, or you can use quadratic formula. If you're going to use algebra, or I just showed you how to also do it on the calculator. Second calc 0. Let's try this one. Okay, when they're having you solve a quadratic, they're generally in the directions. They're going to tell you either you can solve it and give the exact answer, or solve it and give a decimal, okay, an approximate. If they ask you to give an approximate answer, then using the calculator would work. Right. If they ask you to give the exact answer, even if you write down every decimal on the calculator, that's not exact. Even if you write 20 decimal places. An exact answer means you have to use quadratic formula. Okay? But this is not asking for an exact answer. Okay. Any question on how I know it's not asking for an exact answer? Just the word approximate. All right. So we're going to be finding the zeros, which means the first thing we have to do is rearrange this equation so it's equal to what number? Yeah, just like we did in this problem. We want to get 0 on one side. Okay, I like to leave the x squared positive, especially if I'm going to have to try to factor it. So let's move everything to the left. So I'm going to minus the 1 from each side. And how would I move the negative 2x? Yep, so I'm going to add the 2x. And what does that leave me with on the right side?
0.
0. Yeah, there's nothing there. We moved everything. And there are no like terms on the left. Okay, so all I'm going to do is put 2x squared plus 2x minus 1. Okay. If I was going to do quadratic formula, that 2 would be A, that 2 would be B, and C would be negative 1. All right, let's try it on the calculator. Okay, so if you have anything else in there, we just clear that out and try typing in what we have on the left. 2x squared plus 2x minus 1. All right, and before I hit graph, what should I do to set my window?
Zoom 6.
Yeah, we'll just start with zoom 6. The important thing here is being able to see where it crosses the x-axis. Sometimes with parabolas, you want to see like how low they go. We don't really care about that in this one. So if it dips off the screen on the bottom, that would be okay. Right, it doesn't. All right, so how many times does that one cross the x-axis?
2.
2 times. So that means it has 2 solutions to that problem. And if you use quadratic formula, that's why it has plus or minus. Those are your 2 answers. All right, let's start with the one on the left. Can somebody walk me through what do I press to calculate the root that's on the left?
You press like second calc.
Okay, second calc. Yep.
And then 2.
Yep, you go to option 2, which is to calculate the zeros. All right. And what do I have to do? Again, I want to find the one that's on the left side, right there.
You just move the point to the left.
Okay, move the point somewhere to the left of it. All right.
Then you press enter.
Then I got to press enter. Some people move it and then they just move it back. You got to make sure you press enter each time. All right. So I did the left. All right. Now what does right bound mean?
To the right of the point.
Move it to the right of where it crosses the x-axis. Okay, got it.
Then press enter.
Press enter again. Now it asks me one more question. It says guess.
Just like put it close.
Yeah, I just put it close. It doesn't even matter how close you really put it. All right, so I put it pretty close.
And then press enter.
And then press enter. Now, when you're doing this, it is possible, if you have a little bit different calculator, that the number could be a little different. Right? If you round to like 2 or 3 decimal places, no, it won't be. All right, but I got negative 1.366025. Did anyone get like 026 or 024? A little different? No. Okay, so not on this one. They don't tell us how many decimals to round to. So what we'll do is we'll round it to 2 decimal places. What would that be if you rounded it to 2 decimal places?
1.37.
Negative 1.37. So first of all, I'm going to put that symbol, which means x is approximately. Okay? It's not exactly, but it's about negative 1.37. Okay. If I wrote all those decimals down, would that be an exact answer? What do you think? Sam, what do you think?
I think so.
Okay. Well, no, it wouldn't be. Okay? Because it doesn't actually stop there. It just keeps going. Right, the only way to get the exact answer to this problem would be the quadratic formula. Okay. We'll get the exact answer in a second, but let's get the other 0 first. So let's do second calc 0. We'll go to the left, go to the right, and for the guess, just put it wherever you want. 0.37. Okay, so those are the two approximate answers. Let me quickly go through the quadratic formula and show you the exact answer. Because it's important to understand the difference between the two. So if I wanted the exact answer, it would be -2 plus or minus the square root of b squared. Bless you. 4ac all over 2a. And let me simplify that. So that's the square root of 4 times 2 is 8. 8 plus 4 is 12. It's not reduced, but that's the exact answer. That's exact. Again, I can reduce the square root of 12, but I just don't want to do that right now. So if I type in that answer on the calculator, I should get negative 1.366025. Let's see. I get -2 plus the square root of 12, and then divide that by 4. Okay. 0.366025. Yeah, that's the second one. Now, let me do the first one. -2 minus the square root of 12, and then divided by 4. So look at what I got there. Does everyone see how when I typed it in with the quadratic formula, I got even more decimals using the formula than what the calculator gave me? So this gave me the 0.25. This gave me 3 extra ones, 404. But even if you write all that down, that's not exact. Okay? That's a rounded version of what's in that red box. Okay? The calculator only goes, I think it's like 9 decimal places, and then it stops. Yeah, it's 9 decimal places, and then it doesn't give you any more. All right. So is there any question on the difference between an exact answer and an approximate answer? Even writing hundreds and hundreds of decimal places, that is still not exact. You can write millions. It's not exact. Exact has to be something that looks like that. It's quadratic formula. All right, I've kind of already gone through this with you. So how do we find roots graphically? So the method that, I'm just going to reword this. Just erase that. We'll erase it like that. Okay, so to find roots. So to do that, you're going to use what's called the root or the 0 feature on the calculator. You press second, calc, and then it's option 2. Right. Is anybody using a calculator that's not one of mine where it's different? No. Okay. Because most of it, even if you have a different brand, it'll still find the roots, but I just don't know the exact buttons you'd have to press. But on all of mine, it's second, calc, and then it's option number 2. All right, so let's try this one. I'm going to solve it approximately. Now, before we solve it, what's the highest exponent in that equation?
3.
It's a 3. Does that mean that this is a quadratic? The highest exponent is a 3. So what do we think? The highest exponent there is a 3. Is that a quadratic equation? No, what do we think? Why? What's the highest exponent in a quadratic? 2. So you cannot use quadratic formula on that. Okay? So if you wanted the exact answer to that problem, that could be pretty tough to figure out. It depends if something nice happens or not. If nothing nice happens, there's no trick that works here, that's going to be very, very hard to get the exact answer. So most of the time with cubics, for now, we're just going to have to do them approximately. There are ways to do them exact, right? But let's try it approximately. Okay, so let's go back to y equals. Okay, type in, well actually before we type it in, since I'm trying to find the roots, what am I supposed to get that equal to?
0.
Yeah, I'm supposed to get it equal to 0. What would I do on both sides to get that equal to 0?
Subtract 1.
Yep, just subtract 1 on both sides. Right? That's going to give you x cubed plus 2x minus 1, all on the left side. Okay, so we always want to get it equal to 0. Any question why I subtract the 1 from both sides? Okay, so now, oops, what did I do wrong there? Made a mistake. Yeah,
You made the exponent 2.
yeah, I just copied the number wrong. Don't do that. So x cubed plus 2x minus 1. Okay, so x cubed plus 2x minus 1. Any questions on typing that in on the calculator? Okay, I'm already on Zoom 6 because I did that on the last problem, so I'm just going to hit graph. Now, the first cubic that we did at the beginning of class, how many times did that one cross the x-axis?
3.
3. How many times does it look like this one crosses?
1.
Just once. Okay. So I told you that this number isn't a guarantee of how many times it'll cross. It's a maximum number of times it could cross. So it can't cross more than 3. Right. This one just crosses once. All right, so how do I figure out approximately, how about Chase, how do I figure out where it crosses?
You have to use the 0 function.
Okay.
Second, then calc.
Second, and then calc. 0, yep.
It's usually left bound, which is just left of it, and right bound,
Yep, so we'll go to the left and hit enter, right and hit enter.
and then guess close to it.
Yeah, just put the guess kind of close to it. And it tells me that it crosses at 0.45. Last answer. So x is about 0.45. So that would be a skill on the test that if you said, I don't remember where the 0 function is, I wouldn't tell you that it's under second calc. Okay, that's something you would need to know how to do. So you can write it down, on your reference sheet if you're not sure how to get to it. But that's definitely something you need to know how to do. Okay. Any questions on finding the 0 for that one? Okay. So, last thing. So that question we just did, okay, it was a step above a quadratic. That's called a third degree polynomial. But it also has another name. Just like you call second degree quadratic, does anybody remember what you can call third degree? Begins with a C. Yep? No? Second degrees are quadratic, third degrees are Yep.
Cubic.
Cubic. Yeah. So you can call that a cubic polynomial or a third degree polynomial. Fourth degree also has a name. I don't know. Does anybody know that one? It's called quartic. So if you have a quartic polynomial, it means the highest exponent is a 4. And usually above that, people just say it's a degree 7 polynomial, degree 8, degree 9. There might be special names, but they're definitely not used as often as quadratic and cubic. Those are pretty common. So page 80 shows some different kinds of polynomials. That's generally what cubic polynomials look like. The first one that we did on the board, that one kind of came up, it curved, turned down, and then it turned back up again. Okay, I think I still have a picture of it. Yeah, right there. So it kind of looked like the one I drew. They can also curve the opposite way, kind of come down, up, down. This one is up, down, up. Or they can kind of start to take a little bit of a bend in the middle. They never really make the turn, and then they just keep going. That's kind of what this one looked like. It started to make that bend, never really made it, and it just kept going. But in general, that's kind of the pattern for a cubic. They look like one of those. It's a little steeper, less steep, but that's the idea. All right, so let's take a look at this. Okay. Based on the highest exponent, what would you call this equation? Would you call it linear, quadratic, or cubic? Yep.
Cubic.
Yep, that's cubic. Generally, if it's written in what we call descending order, the cubic term should be first. But if you write something like this, that's still cubic. Even though it's not written in the right order, there is an x to the third power. Okay, but usually when I write it, let's see, I'll always put the x cubed first, and then if there's an x squared, it would go next, and then an x, and then the number without the x. All right, so before I draw it, what is the most number of times this graph could cross the x-axis? 3. 3. There's no question. Could cross 3. If it crossed 3 times, it might look something like that. Is there a way that it could cross twice? Yeah. Twice would look something like this. It would go through it, and then it would touch it and go back up. And once, yep, definitely could do once. We saw that. Could look something like that. But you can't get 0. It's impossible to have it cross 0 times. All right, so let's graph that. So we've got x cubed minus 5x squared plus 6x minus 1. And all right, I think looking at that, that's a pretty good window. How many times does it cross the x-axis? 3. Yeah, there's 3 different numbers you could plug in for x, and it would come out to 0. So it crosses 3 times. Now example 6 is using the question we just had. Find the one that's in the middle. Okay, there's 3 of them. So by the middle, I mean this one right there. Ileana, can you remind me how I use the calculator to figure out where it crosses the x-axis? Yep, second, calc, and then option 2. And Cadence, what do I do from there? Yep, I gotta hit enter somewhere to the left of where it crosses.
And then to the right.
Yep, perfect. Go to the right, hit enter.
And then guess.
Yep, you just put the guess kind of anywhere in the middle there. And if we round that to 2 decimal places, what would be my answer where it crosses? Yep, 1.55. Okay, and remember, that symbol means it's approximate, it's not exact. Okay, any questions on that? Okay, so that, I think, is section 2.1. Okay, so what I'm going to do is I'm going to leave that up. We got plenty of time. We got about 25 minutes left. So please use the time to try to start that. And while you're starting that, I'm going to put a list of topics that are on the test on the board. Okay, so there's a list of topics that are on the test. So determining if a graph is a function using the vertical line test. Finding domain and range of a function. We talked about doing that different ways, using either intervals with the brackets and parentheses, or writing it as an inequality. That's using like greater thans and less thans. I'm going to give you a value to plug into a function, and you just have to tell me what you get for a number when you plug it in. We talked about when we shift parabolas, like left, right, up, and down, how it changes the vertex. Okay, I'm going to give you a vertex, and I'm going to ask you to tell me the equation of the parabola based on knowing its vertex. Transformations of parabolas. So something like I might say, give me an equation of a parabola that's been shifted up 2 and stretched vertically by a factor of 5. Okay. Or I could give you the equation and you tell me what's been done to it. And then the last thing, that was what we did today, calculating roots on the graphing calculator.